Yeah, so that's the subject. How do you say it?
Le Petit Prince.
Le Petit Prince. Right. So you know when Anton de Saint-Exupéry. Exupéry, right? When he was doing that, making this book up, at that time, they knew about 9, maybe 8, probably 9 planets. I'm not sure. That was it. They had the asteroid belt, so they knew some other things going on, but they had just the possibility of a place like this, where you could stand on which essentially is a small planet, was possible. But he had no idea how possible it was, because since that time, they've discovered, not hundreds, not thousands, not tens of thousands, not hundreds of thousands, not, trillions of these things. And the one that we visited most recently is bigger than this. He can stand on this, and actually you can stand on any one of these things, provided you don't move. Okay, but if you happen, in his case, if he was standing there and he happened to be, wiggling his toes, that would give him escape velocity from this planet, and he'd be gone. But the newest one, the one we just visited, I don't know what the gravity is, but I have a feeling that you could literally jump off of it, and you'd have to do quite a bit of a jump, I think, to attain escape velocity from this new planet, this new object which we visited. It's called Ultima Thule, and no internet. That's so nice. Hold on, guys. This is coming in. Ultima Thule, which apparently is a place beyond the borders of the known world. So, literally in this last week or 2 weeks since I have not been here, 3 weeks I think, we have visited 2 places that we've really never ever been before. The dark side, far side of the moon, and the furthest that human beings will probably ever reach with a camera, certainly in your lifetime, probably in your children's lifetime. Because nobody's going to go further than where we've gone with a camera, because we'd love to go there, and there are plenty of places to visit, but the reasons decrease as the time goes on. We want to know how the solar system was created. That's our goal, more or less. And then, of course, secondarily, is there life, or maybe primarily, is there life on other planets? Because if there's life on other planets, then there's life everywhere in the universe, and if there's not life on other planets, then we don't know anything. So we're going to Ultima Thule. We went to Ultima Thule. Where's the picture? So this journey started, I think, in about 12 years ago, when we went set our sights on Pluto, and having passed Pluto and sent back a beautiful bevy of pictures, we set our sights on going further at a further place. And Ultima Thule was discovered literally after we had passed Pluto. They literally found something that they could aim for, and that's what it looks like. We've just passed. This is the first picture. The interesting thing is that this is the first picture, and it will take well over a year, almost 2 years, for the set of pictures that they took flying past at 31,000 miles per hour. So they swept past this thing at 31,000 miles per hour. It'll take them 2 years to send it back, because it's so far away and the signal strength is so weak that they literally have to dribble the data back. If you're making data and you need to send a series of of ones. Should I turn this thing? Sure, I should turn this thing. If you need to send a series of ones and zeros, 1, 0, 1, 0. If you need to send ones and zeros, but you're sending it from 6 light hours away, 4 billion miles away, you don't send ones and zeros like that, because that would look like this. It would look like nothing. So when you send a 1 and 0, you send a 1 for a long time, and then a 0. And that way you can tell the difference between the 1 and the 0. So the bits are longer. The bits are longer. And so you can only send so many at any given time. So that means that the pictures take a day or so more to come in, and they have hundreds of pictures. So they're going to take hundreds of days to send it. Right now, we only have this one picture because the spacecraft is literally behind the sun, and so we can't point the telescope at the sun because it's behind the sun. So we're waiting for the sun to get out of the way, the Earth to move around a little bit so the sun can get out of the way. Yeah.
What speed is this thing moving?
That's a good question. I don't know. I'm going to guess. Okay. The Earth is moving something like 20 miles a second. Okay. And the further you go out, the slower these things move. So by the time you get not one Earth distance, but 30 Earth distances, it's probably going a 30th, maybe. So at least I'd say 1 kilometer or 1 mile per hour in orbit, more or less. That's a good question. The picture is interesting because one of the things I think is really interesting is they, without a telescope, they were able to determine the shape of this. Well, they used a telescope, but the telescope could not possibly, in a zillion years, resolve this object. Nevertheless, they knew what it was going to look like before they got there, because let me show you. So before they got there, they okay. So what they did is scientists, like 50 astronomers took 5 telescopes and went 5 different places in the world, so they could point the telescope at Ultima Thule and take a measurement of Ultima Thule blocking out a star. So it would let's say this is the star. I don't know which one of these it is, and maybe in this picture it actually shows it blocking out, but I don't see it. What they did is they pointed their telescope at this spot in the sky, knowing that Ultima Thule would be passing in front of one of these stars. And the shadow of Ultima Thule on the Earth was the idea. Find the spot on the Earth where that star... oh, it's there. Did it go away?
That's the one.
That's the one?
Wow.
Uh-huh. Find the spot... There, look at that. So they find the spot on the Earth where Ultima Thule is going to block that star, the shadow of that star via Ultima Thule on the Earth. Put your telescope there and just measure. And just to be sure, let's distribute telescopes all across the Earth so you can watch the shadow come and go. I just love the fact that there are people who are dedicated enough to go all across the Earth to weird-ass places on the Earth. And this is what they saw. They saw the stars being blocked by an object which would... This was a model of what it could be, and the actual object that was this. So they knew this going in. Isn't that cool?
That is amazing.
It's amazing.
It's amazing.
Right. And 5 expeditions, had more than 5 expeditions. You can see there's 1, 2, 3, 4, 5, 7 expeditions, but only 5 of them caught the dimming of the light. Right? Can you imagine that? I just can't imagine the dedication.
Mind-boggling.
Right. And why were they doing it? Yes. Why?
And how did they know to be on the alert for this? Had they seen Ultima Thule before?
They knew they could see Ultima Thule in a telescope. Okay, and they could see its trajectory, and they could see that it was going to pass in front of a star, all known ahead of time. So they just had to climb on their jet planes and go across the world to find it.
I missed the first part of your diagram. I just missed your words.
The
Ones and zeros.
in order to send a bit that can definitely be received by a telescope, you have to make the bit longer. You have to turn on the volume, on, off, longer than on, off, on, off, on, off, on, off, because that could be missed, right? Because there's lots of noise. There's lots of noise in space, radio noise. So because the signal to noise ratio is not sufficient, you need to make the signal stronger. You can't make it stronger, but you can make it longer. So
Do they
why?
have a sense of its size?
It's I think it's about 20 miles, 30 miles long. And maybe 15 miles wide, which makes it bigger than the asteroid that we previously visited that took pictures that looked very much like this, was also multi-lobed.
Right.
That asteroid was smaller.
That's the one they can land on, sweep off some stuff, and come back.
No, that's the one we visited a while back. The
one that we landed.
the one that no, we didn't. We landed on it, but didn't do such a good job landing on it.
Okay, gotcha.
Here, this is the one we landed on. We sent a probe to the surface of this object. It's coming in. It will come in. These are actual pictures of that multi-lobed asteroid or comet that we visited. Absolutely beautiful. I'll put up one of the pictures. This one.
Yes, there.
Right. So it's and we did land on this, but the problem is that the thing that landed on it took a bad bounce, and so it was supposed to land and sit there and point back at the Earth and tell us stuff. But what happened is it bounced, and when it bounced, it disappeared, and we couldn't find it for a year. And we finally found it, but it did send back some information, but it didn't do the best job.
Is this about the same size?
This is smaller.
Smaller.
This is considerably smaller. Else and Manhattan. Yeah, so there's a picture of it lying over, sitting up over Manhattan. Here it comes, if it comes in at all. It's about as large as Central Park. That's what the caption here says. That's the previous comet we visited, and we visited it. We orbited it. We spent 2 years there, and we landed on it. That's different from flying by at 31,000 miles per hour. Very different. It doesn't seem to want to come in. Okay. Yeah, so there's another picture of it hanging over Manhattan.
Yeah.
Okay. But this one's bigger than Manhattan. Probably twice as big as Manhattan. Okay. So, what story am I telling you next? So the picture of it. Why are we interested in it at all? Because it tells us about the formation of a solar system. It tells us solar system has been around for 4.5 billion years. How did this thing happen? I'm amazed that this could happen at all. If you think about how big space is, and you can't think about how big space is, but because space is there's no way that I can tell you something that will say, oh, I get it, how big space is. For me, the easier thing is to understand that this, as far as I'm concerned, is impossible. Because these two guys, which formed obviously separately, because it's clear that these guys did not form together. They formed separately and then they came together. So somehow or other, in the emptiness of space, they found each other, which I think says something about how crowded empty space is. Certainly then. You're making a star, okay? You have a cloud that's a light year in diameter. Okay, that cloud is going to come together and it's going to make a star. It's going to leave behind 9 or 8 planets. But in the process of doing that, it's also going to leave behind an enormous amount of other stuff. And the other stuff is the cool stuff that I am just fascinated by as I think about these things. This is one piece of other stuff. And it's so far beyond Pluto that if you think Pluto was in empty space, this is even more so. How did this get formed? Well, apparently they have the idea that it formed like this. So that empty space wasn't so empty. It was filled with schmutz. All right, and how the schmutz made its way to other schmutz? Was the gravity? Was the gravity doing this thing? Did these incredibly small things with the incredibly small gravity that they have find each other? Remember, they had to be going slow. So they are going slow with respect to one another and with respect to going around the sun. So they're all traveling around the sun, which has just formed. And when we use the word just in astronomy, the word means within the last 10 million years, which is, astronomically speaking, an instant. Because it's not 10 million, the Earth is not 10 billion, but half of that. So 10 million years is a very short period of time. During that 10 million years, and maybe longer, these guys were finding each other, swirling together somehow or other, and somehow two of them got made, and then somehow or other, these two got together. You can't do this. You can't put this together and make this without extra help. Because two bodies, and I always tell you about how orbits are in ellipses, well, these two bodies would would rotate around each other forever unless they got some help, maybe from some more schmutz. Because as soon as there's a third thing, then orbits don't do this. Eventually they do something else, and then so eventually more schmutz happened and they got together like this. The more schmutz is what you're looking for, because see, the schmutz that hit it has left its imprint on these bodies. So as they swim past, they're looking to see what the original environment was that these things formed in. And what they're going to do is they're going to count the craters. And they're hoping that when they count the craters, they will be fewer than they expect from just general bombardment. And if there's very few, it will tell them that everything that they're seeing that isn't a crater is literally part of the original comet or asteroid, whatever you want to call this, or actually what that has a name. I'm going to give it a name now. It's a KBO. For those of you who are at home watching this, that says KBO over there, but I just didn't turn the camera. Okay. So that means Kuiper belt object. Kuiper belt object. There's a guy named Kuiper who said, I think there are lots of things out there beyond Pluto, and I have proof. And he says, and my proof is comets. These comets, they come from somewhere. They're coming from beyond Pluto. There must be others out there. I bet you there's a whole belt of them. So he got his name behind what essentially now is billions of things that we're finding, of which this is the second one we visited. Does anybody have any idea what the first one is that we visited? You all know the name, Pluto. Pluto was the first Kuiper belt object. See, when Pluto got demoted from being a planet, it got elevated to being the chief Maki of which, by the way, is the name of another planet, Maki. But it got to be the chief planet. Pluto is the biggest. Actually, not even the biggest. Not even the biggest. There's one that's bigger. Actually, not bigger, but more massive than Pluto. But it got to be the first. And then it took 60 years more to find the second, which they found. Now, literally, they have hundreds. Well, no. Actually, thousands of things that they literally know the orbits of, and some of which we have names for. So maybe there's 200 objects that have actual names that people said, who would like to vote on this name, and they got it. So we have named objects that aren't just numbered objects, but names of those.
Aren't they all part of the Kuiper belt?
They're all part of the Kuiper, but
You're not going to name every little.
no, not every one, but this got a name. It had a number. Its number is up here. 2014 MU69 was its number and name. That was, and you don't have to. That's not a vote. The 2014 is when it was discovered. The M turns out to be the half year in which it was discovered, and the U has to do with the month that it was discovered, and 69 has to do with the which number object it was during that half month in that year. And so you don't have to invent a name. It's already made for you by the sequence of discovery. The name Ultima Thule obviously was cooked up by a group of people who now somebody has said, let's call this one Ultima, let's call this one Thule. Okay, I don't know if that's going to stick, so when they see better pictures of this, it's going to have craters, and we'll know what the story is. It'll tell us about the formation, not only of this object, but the formation of the solar system itself. We really want to know how these things came together, stuck together, what they're made of, and the like, and we'll be able to tell. It's also look at the color. It's also reddish, which tells you immediately that there's methane on the surface of the thing. So they'll be able to tell more about the surface composition as well. And they've taken all the pictures already, so it'll just take another year and a half for it to come back. Yeah.
Haven't they suspected that there may be Earth or Mars-sized objects out there in the Kuiper belt that we have no idea where and when they are?
Yes, sir.
I've read that, and I wasn't sure I understood it.
Yeah, no, that's okay. For one thing, so this is our solar system, as we know of it. So this is our solar system as we know, and you can see there are 8 planets plus Pluto. Pluto's doing this weird number. Oops, I'm sorry. I want that. Okay. So Pluto's doing this weird number, where it's sort of, see, everything else is in one plane, literally almost perfectly in the same plane. So when you look up in the sky, and there's Jupiter, well, Mars is here, and then Uranus and Neptune, they're all lie in a plane. You look up in the sky, they more or less lie in a plane in the sky, and if you're outside the solar system, they also lie in a nice flat sheet. Everything but Pluto, which is off kilter, and of course it's off kilter because it doesn't belong with the planets, it belongs with the Kuiper Belt. So other things, so they have discovered a few years ago, as I said, many objects, many of which are actual planets or minor or dwarf planets. I spoke to the guy who wrote this software in the first place, and he and I got together, and I supplied him with the orbits of 20 additional planets, and he supplied me with the technique to put those 20 additional planets on this diagram. So with his help, I was able to do this. So I'll just flash. So these are all Kuiper Belt objects, but they're not just objects, they're also dwarf planets. And among those are there's Eris. Eris is one that's bigger, more massive than Pluto, but not. It's about the same size, but more massive. And so if Pluto deserves to be a planet, well, for God's sakes, Eris does too. And the 20 of these that are there also deserve to be planets. If you're gonna restore Pluto, you got to restore Eris and all these other objects that I've got going here. But my favorite object of all, by far, is a little object that was discovered a few years ago by the name of Sedna. Where is Sedna? Hello, Sedna. Where are you, Sedna? Ah, there's Sedna. Hello, Sedna. That's Sedna.
Wow.
And so Sedna, look at Sedna, because Sedna is crazy. That's Eris. I mean, that's Eris. That's Pluto. Okay, the blue thing in there is Neptune. So this orbit is Neptune. You can see that Eris, that Sedna, is further from Neptune than Neptune is from the Sun. Neptune is closer to the Sun. 3 Neptune distances away, you find Neptune. You find Sedna. So Sedna was never, at any time in its lifetime, influenced by Neptune. How did it get into that orbit? How did it get thrown into that crazy orbit? Because if you're trying to make a planet, you can't make a planet that's doing this. Impossible. Why is it impossible? Because all the little pieces that want to come together to form a planet are going at each other like this, and they hit each other and destroy each other. You have to get something in a nice circle. Everybody can agree on a nice circle. Then all the little guys come together. Ultima Thule is going around the Earth in a circle, going around going around the Sun in a circle. Ultima Thule is, so it could be made. But Sedna couldn't be made because all those particles would have different points of view as to which way it wanted to go, and they'd be crashing into each other. So ultimately, Sedna was also made while it was traveling around the Sun in a circle. And something kicked it out. It couldn't form that way, it was kicked out. Planet 9 is the answer to that question. Where is Planet 9? There's no doubt in most astronomers' mind that there is a Planet 9. Sedna is a little tricky because it's really weird. And the possibility is that Sedna achieved its superstar status by being kicked in the pants by a passing star. And that makes sense because passing stars were the norm when the Earth was formed. because the Earth was formed. See, I told you about this cloud that's 1 light year across that decided to become a star and leave behind some planets. Well, actually, the gas cloud that was a mile or light year across was probably a couple of light years across, and it didn't form one star. It formed many stars. Probably about 1,000 stars were formed at exactly the same time that the sun was formed. Because stars don't get formed by themselves. No star is ever born by itself. It's always born in a nursery with thousands of other stars. And it's fairly dense. The stars are fairly close together. So since they're so close together, they can interact with each other, play ping pong with each other, and bocce ball, and not necessarily hit each other, but influence each other. So they could easily have passed close to the sun after Sedna was formed, but to kick it into this kind of orbit. So it doesn't necessarily. Sedna is not the one that tells you about Planet 9. It's Eris that tells you about Planet 9. It's those other closer in planets that could have been kicked by something that's still out there. So there's lots of evidence for Planet 9. Sedna is not one of them. And by the way, they have a new one. It's called the Goblin, and it's twice as far out as Sedna is. So I'd love to put it on this diagram, but I don't want to call Stuart Levy and say, excuse me, could you help me one more time? He's probably a busy guy. I know he's a busy guy. He's busy making another planetarium, which is, by the way, is cool. On the 30th of this month, I have been asked to give a lecture to the Amateur Astronomy Club, and that lecture will be all about software that you can use to do this sort of thing. Okay, this particular piece of software is called PartView. It was created by the Museum of Natural History. That was about 10 years ago. Now they're doing it again, and they're making planetarium quality software that's available to the general public, and it's out there now in its early form. And I'll be talking about that as well, but Stuart Levy, I think, is working on that as well. And it's much cooler than this, but harder to operate, but much cooler than this. So I'm going to be talking about that at some point on the 30th of this month. Okay, what's my point next? What's my next?
You were talking about Planet 9.
Planet 9 is not really what I want to talk about.
Okay.
I just am saying it's out there, and this is proof, or somewhat proof. We actually will do a thing on Planet 9 all by itself. So Ultima Thule. So the Kuiper Belt in general. Hold on. Okay, so this is a diagram which gives you some idea of what this Kuiper belt is like. This is not where it is in the sky. This is a diagram that it tells you two things about any object, or three things. It tells you how big the object is. That's Eris. There's Pluto. There's Sedna. There's the one I was talking about, the Goblin. Okay. So that gives you a sense of size. This scale over here is distance. So the further out you go, the further something is, and this is logarithmic. So the fact that this looks like it's just twice as far as this, it's not true. It's 10 times as far as that. So these guys are in close to the Sun, Pluto being the closest, if you will, of these Kuiper belt objects. And then they have different colors. And they have different colors because they belong to different partnerships. Some of them, like Pluto, colored red in this You notice they're stacked up vertically. And this vertical axis is actually called the inclination. How inclined the orbit is to the plane of the solar system. If it's inclined like Pluto is, like, off maybe at a 15-degree angle or whatever, then it's up here at 15 degrees. And if it's further inclined, then it's higher and higher and higher. And if it's less inclined, it's lower and lower and lower. Most things lie within 30 degrees of the plane. But that's what this axis is telling you. But there's also one other thing that it's telling you. See, they're all lined up in this little column. Why are they lined up in a little column? And they're lined up in a little column because they all belong to the same family. And that is the family that plays tag with Neptune. If you want to be a Kuiper belt object, then you either better avoid Neptune entirely or play tag with it, so that when Neptune is here, you're here. And when Neptune is here, you're here. If you don't do that, and you are not coordinating your residence with Neptune, then Neptune will capture you and throw you the hell out of the solar system. So those objects have stayed around for 4.5 billion years because they know the rules.
Where would the Earth be on this plane?
The Earth would be, on this scale, probably very close to, let's see, 30. This is 30. This is 40. Okay, so 100, 90, 70, 60, 50, 40, 30. Earth is with 1. So on this scale, it's not on this scale. It has to be somewhere down here. Oh, and the Earth would be exactly at 0 on the inclination.
We're on the equator.
Right. The Earth would be
So
at
we're measuring
here.
things based on something that we decided.
No, it's not. No, it's not arbitrary.
It's
It's
not
it's not.
related to the Earth.
It's not the equatorial coordinates. It's the celestial coordinates based upon the plane of the solar system. The solar system has its own plane, which is inclined to the Earth's equator by 23 degrees. Okay, if the Earth tilts its north pole by 23 degrees to the plane of the solar system. So if the Earth tilted back up, it would be upright, and it would be going around the sun like this, but it's going around the sun like that. Pluto and the other Plutinos, they're called Plutinos, okay, are going around the sun avoiding Neptune. These guys over here are called, and I love this, and I'm even going to turn the camera so that the viewing audience can enjoy it just as much as me. It's called all those objects are called QB10s. They're called QB10s because, see, the Q is normal, tells you which part of the year. The B tells you which part of the month. The 1 means the first one. This was the first object that was found in the Kuiper belt, and it got that name. And when they found more, they didn't have a name for what those things were, so they called them QB10s. So all of these are QB10s, even though there's only one of them that is actually QB1. I think that's very sweet. Astronomers showing absolutely no imagination whatsoever, but needing to talk about something nevertheless. So that's this grouping here, and then you see these guys. They are white, and these guys, these white guys have been. Oh, I should turn the camera. Thank you very much, Kurt. I thought you were waving to me. I was. These white guys, they have been thrown around by Neptune, and they're called the scattered disk. So these guys have been thrown by Neptune into crazy places in terms of inclination and in terms of distance. You have a question?
Why Neptune? What?
Yeah, I was gonna ask that.
Why Neptune?
Right.
Very good question. There's a very good answer.
Good.
Okay?
Nice.
No. Because Neptune was one of the most viciously bad boys of our solar system in the early time of the solar system. It's a theory. We have a theory. I love the theory. I don't care whether it's true or not. Usually I care whether things are true. This one, I think, is so remarkably beautiful that I don't care. It's in the early time of the solar system, there was stuff going on like you wouldn't believe. Wait for the video here. Come to me, Kula Kule, O frabjous boy. Come on. I'm not asking for much. This is a cartoon. It's here you go. Okay. So here's the solar system in the old days. We don't bother with the terrestrial planets because they're not consequential and they're somewhere in here. Okay, we're talking about here. We're talking about Jupiter, Saturn, Uranus, and Neptune. Actually, let me correct myself. Jupiter, Saturn, Neptune, and Uranus. Uranus was the furthest from the sun. Neptune was the second planet. Why? We say if you're making planets, you got to make planets where the stuff is. So if you're making planets where the stuff is, you don't make them all the way out there. You make them close in, where Jupiter and Saturn. Jupiter ate most of the stuff, then Saturn ate a lot, what was left over, and the little dregs were left for Uranus and Neptune. But close in, closer to the sun than Uranus and Neptune are now. That's Neptune. That's Uranus. This is million years. 880 million years after the solar system was formed. This video runs, and you'll see something remarkable happen. What you're going to see, it's going to happen very quickly. What's going to happen is that Jupiter and Saturn are playing a little game with each other. And while they're playing a game with each other, Uranus and Neptune are being affected by the game that these two are playing with one another. The game is basically a resonance game. I'm here, you stay there. I'm there, you be here. So that's what Jupiter and Saturn are doing. And meanwhile, Uranus and Neptune are caught in the crossfire, and one of them gets moved, and the other one pays the consequence. And this is the other schmutz that's laying in the solar system that's close in. This is close in. This stuff is going to be messed with. This stuff is going to be turned into the Kuiper belt, but it's not yet the Kuiper belt. The Kuiper belt is way out here, and this stuff is way in close. All this stuff gets thrown.
Did you just say schmutz?
I did. You were not here during the earlier part of the time. I've been saying schmutz all day.
Right.
Uh,
Do you need a translation?
nah.
Dirt.
Dirt. Okay, so look. So the time is 800 million years ago, and look the orbits. They switch. Neptune flies beyond Uranus and throws out all that schmutz. So all of that stuff is scattered into the Kuiper belt, leaving behind just a little bit of stuff. Leaving behind just a little bit of stuff. So that's why I blame Neptune. So this is the same video starting from the beginning, which I started before I started in the middle. This is called the Nice model, and it explains a lot. It explains the reason it's people love it. The reason people love this is because it explains why we're here today. Because that schmutz that I'm talking about consists of mostly water. And the Earth, supposedly at this time, was missing a lot of water. In fact, when you're trying to invent the Earth, and you're building an Earth from theoretical models, at some point you turn around and say, you know, this thing doesn't have water. Water doesn't condense on the planet Earth as it's forming because it's too hot. The water boils away. The gas doesn't settle on the Earth. So you're missing water if you're inventing an Earth. This stuff is mostly water. And when this stuff gets thrown around, it's also thrown around into the inner solar system. And in the inner solar system, the Earth is sitting there and the moon is sitting there, and that's how we get the water. Supposedly. It may not be true. I just love the story. Yes.
Is the early bombardment the same thing? Or is
The late bombardment, I think it's called. The moon was bombarded by. The moon was bombarded by. Let's bring up the moon. There's the moon. It's got all these craters. You see the. Who's talking? Somebody talking?
Hi everyone, welcome back to Cody's Lab. So you might have seen those scale
Shut
models
up.
of the solar.
Okay. So there's your moon. Okay. There's your moon. It's covered with Maria, right? Those dark areas, right? Those dark areas are craters. The moon was hit by gigantic things early on in its history. We actually have dates because we went to the moon, we picked up some rocks, we brought it back, and everything that we picked up on the moon is missing half a billion years of lifetime. Everything on the moon is half a billion years younger than the moon because the moon was hit and stuff was melted, and the stuff that melted reset the date when it starts, because as soon as you melt something, you reset the date. So when they say how old something is, obviously it's as old as the universe, but when it was the last melted is the date that they talk about when they're talking about the age of anything. The moon was last melted not 4.5 billion years ago, but 3.8 billion years ago. And that schmutz that we're talking about hit the moon, made those craters, brought water to the Earth, and gave us the oceans. If that's true, it's the best story. I'm sticking with it until I come up with a better one.
So why didn't it bring water to the moon?
The moon can't keep its water because it doesn't have the gravity. It doesn't have the atmosphere. So if it did bring water to the moon, it disappeared. Right. The Earth has enough gravity to keep it. Yeah.
Well, how did the Earth? It had no water because water was boiling away.
Right. Or gas didn't condense, if you will.
And now, why doesn't that happen again when the new water comes? Why doesn't that fail to condense?
Well, no. See, the stuff that's hitting the Earth then from the schmutz that we were talking about 2 seconds ago, that schmutz is already in a bottle. Okay, it's already contained in a object. So the object hits the Earth, and then it's on the Earth.
What's
You
the
know.
object?
The object is the comet or the asteroid that hits the Earth. So it all comes in as one thing. A little bit of it boils off while it's going through the atmosphere, but if it's big enough, very little of it boils off, and it just lands on the Earth. And it does, horrible things, but nobody's around to care. So supposedly, that was the origin of the water that gave us life, on some level.
What's horrible about it?
We weren't here to watch. I'm imposing you. It's a good question. I'm imposing my point of view as a human being on the event.
Missed the show.
Missed the show, right. Which brings us to the other thing that happened this week, which is, so this is the moon as you normally see it, but this is the moon as I like to see it. Come on. Come on. This isn't a web game computer. This computer is 10 years old, so it's a little slow, but still amazing. It does not have to reach the web in order to be able to do this.
There we go.
No, I'm just moving it.
Oh,
It's still not coming in.
It's not rotating.
No. There you go. One more. See, so this colorized version of the moon is you're much more able to see the craters that, in fact, that define the Maria. But the colors are literally tell you how deep something is. The bluer it is, the deeper it is. The redder it is, or the more orange it is, the higher it is. So you can see the highlands, and you can see the lowlands, and you can see the Maria. That's the front side of the moon, presenting the back side of the moon. Come on down. That's the back side of the moon. You can see that the back side of the moon has a lot of highlands, right? Look at that. Wow. That's quite amazing, right? We talked about why the moon is like that in the first place, and maybe for those of you who are either asleep or not here or not paying attention, which more or less covers 90% of you. I said last time that the moon could have gotten that way because the moon was formed when there were two moons in orbit around the Earth. You know, something collided with the Earth, made a ring of schmutz. I like the word. I'm going to keep using it. And then the schmutz condensed into a moon. But the new theory is two moons. The two moons came together slowly and coalesced, and one got squished onto the backside of the moon, and so that's the backside of the moon, which contains the squishy remnants of the moon that collided with it. So that's maybe why the highlands are like that. What's this? What is this? If something is blue is deep, then this is very deep. Well, it's sort of round, so guess what it is? It's a crater. This is the biggest crater in the solar system. It doesn't look like a crater anymore because it's been messed with by the other craters. So it doesn't look so, but the depth is clear. It's a crater. Well, the Chinese, where do they go? I put a place marker. So, there they are. The Chinese have landed in Von Karman. So you think if they were going randomly, they didn't just go randomly, they went inside this giant deep hole in the moon on the far side. So they're right here. And although landing on the moon by itself isn't that spectacular, landing on the backside of the moon is certainly more spectacular. But landing in this particular place, you got to give them credit for at least going someplace which is interesting, because that looks like probably the oldest part of the moon, right there.
Why is it more difficult to land on the dark side of the moon or the far side of the moon than where we landed? What makes it more difficult?
Well, you can't talk to the spacecraft.
Right.
Okay.
You
Right,
can't
but they
see
put
it.
something else in there, right?
They put a satellite up.
So they put up a satellite. So here's the story on that one. Oops. I put up a satellite. How do you put a satellite up that doesn't that you can use so you can always see it in the sky, so that you don't have to. So you can always talk to your rover on the surface of the planet. You want to be able to talk to it all the time. You want to be able to send pictures. You want to be able to tell it what to do. But if you send up a satellite around the moon, it's going to go this. It's going to do this. That's not okay, because sometimes it's behind the moon and sometimes it's in front, and it's not talking to. You need to put it. How do you put something up in the sky that's stationary? Stationary. How do you do something stationary in a world in which there's things that are orbits? Orbits. Things go around. They don't just. How do you do that?
You put it so that it moves at the same speed as the rotation of the moon.
Okay. Do you put it in the same, in a way so it moves at the same speed as the rotation of the moon? And the answer is yes. I'll show you how, first of all. This is one of my favorite pictures. It's a cartoon. Yeah. So